All right, so this is my week 2 problem 3 video explainer. So this problem involves a bar or a rod of mass m, and it is connected to two surfaces by a string A and a string B, and the distances dxl, as indicated in the diagram, are the distances away from the point of rotation. And then there's also a little cube of mass 2 that is resting on the bar. And over here I just drew just a free body diagram showing the direction of each force in the system. So we have the torque of string A, the torque of string B, and then the mass times the gravitational constant, being m1 being for the bar, and the m2 being for the cube that's resting on the bar. So one important thing to note here is that so we're dealing with a rotational equilibrium condition about the string B. So the net torque for string B is going to be 0. So using that information, we're going to use all the forces that are acting on string B to solve for the torque of string A. So, like I mentioned before, for string B, it is in a rotational equilibrium condition. So we're going to set everything equal to 0 and put all the forces acting in on the left side. So we have the torque of string A times d, so that being the distance separating the string from the point of rotation, and then minus the m1, so mass of the bar times the gravitational constant times L over 2, and that being the distance of the point of rotation for the bar, and finally x being the distance for the cube. So after just a little bit of simplification, we find that the torque of string A is equal to, just after some simplification, gravitational constant times mass 1 times the distance L plus 2m2x all over 2d. And just right over here I noted that the net force for the torque of string B is going to be 0. And that's how we ended up solving this problem. Just a couple tricky things, I guess, is noting, first of all, just realizing what condition we're dealing with in this problem, and also identifying what all the forces are that are acting in this system. And this just relates to what we're learning with class in relation to just finding different rotational equilibriums in this problem, and also just the idea of torque. So yeah.